All right, everyone, welcome to this first video in chemistry online where we're going to learn about the different states of matter. And to talk about the different states of matter, we're going to use this chart that's on your screen before you. If you take a look at the y-axis, you'll see that as you go up, the temperature is increasing as you go up. So let's talk about what the x-axis is. Well, the x-axis represents heat. And so as you add heat to a substance, obviously the temperature will increase. Now, if we start all the way over here, you'll see that we're starting with a solid. And as we go this way, as we add heat to it, you can see that solid does increase in temperature and eventually will become a liquid once it gets hot enough. And if you were to continue to add heat, eventually that liquid will get hot enough to become a gas. And so that's an overview of what this particular graph is showing us. So again, as we add heat, the temperature of the substance increases and it goes from a solid to a liquid to a gas. Now let's go ahead and talk about the different parts of this graph that we need to fill in. We want to talk about the compressibility of the different states of matter. And so again, we're going to focus on solid, liquid, and gas. And so solids are not compressible. They're not compressible. For example, I've got this calculator here. It is a solid, and I can try to compress it, but it's not compressible. Now, some of you might be thinking of like a teddy bear. A teddy bear, oh, we can totally, compress a teddy bear. But the reality is that inside the teddy bear, there's a bunch of gas inside of it, a bunch of air inside of it, and you're not really compressing the solid itself, but you're pushing out all the gas. Now, liquids also are not compressible, but gases are compressible. They're very compressible. You can compress gas a lot. You can take a big volume of gas and compress it into a very small area. Now let's go ahead and talk about the shape and volume of solids, liquids, and gases. This right here has a definite shape. It is definitely this shape. And so we're going to say that the shape of a solid is definite. Now, what about the shape of a liquid? Well, let's think about the liquid inside of here. As I turn it around, the liquid is changing its shape, and it's, if I put it into a different container, it's going to take the shape of that container. So it's not definite, but indefinite. And then we have gases. Inside here is a gas. And if you take a look, here's the shape of it, if we think about the gas inside of here, but I can change the shape of the gas. And in fact, if I put this in another container, the shape of it will change as well. So again, this is going to be indefinite. Now, talking about volume is how much space something takes up. And so if we think about a solid, when we think about the calculator here, how much space does it take up? Is it definitely this much space? Or can it take up a different amount of space? Well, it's definitely taking up this much space. No matter where I put it, it's definitely taking up that much space. So this is definite as well. So for volume, a solid has a definite volume. So the amount of space it takes up is definite. Now, what about for a liquid? Well, if we take a look at this is taking up this much space. And if we were to pour it into a different container, it actually would take up the same amount of space. It might be a different shape. It might, be more spread out or whatever, but it's still going to take up the same amount of volume. To give you an example, it would be hard for me to put this inside of here because this is too much volume to go inside of that coffee mug. Now, so what that means is that it is a definite volume. So Now, for gases, you can actually take a gas and you can compress the gas. We've already kind of talked about that. And if you compress it, you'll see um, that it actually can be a different volume. You can take gases that have a large amount of volume and you can compress them to a small amount of volume. And you can take gases that have a large amount of volume and you can put them in a container that has even more volume, and essentially whatever container a gas is in, that's the volume it will take. And so that is an indefinite volume. Okay, so let's go ahead and talk about what we call going from one state of matter to another. And I'm going to go ahead and change the color here to purple. And when we go from solid to liquid, we call that melting. But what about when we go from a liquid to a solid? Well, we call that solidification. Another word we use is freezing. So solidification and freezing are both words that we use. Now, what about when we go from a liquid to a gas? We call that vaporization. And what about when we go from a gas to a liquid? Well, what do we call the liquid that's on our lawn in the morning, or the liquid that's on our mirror after a shower? We call that condensation. And so that's the different terms we use when we go between states of matter. Now, if you take a look in the little diagram in the upper left, it's the same, we're going to fill in the same words that we just used to describe going between the states of matter, except for obviously we're going to add in there going between a gas and a solid. So let's go ahead and go fill this in. So when we go between a solid and a liquid, we go from solid to liquid. Again, that's melting. And when we go from a liquid to a solid, we call that solidification or freezing. Kind of hard to fit that word in there. Now, when we go from a liquid to a gas, we call that vaporization. And when we go from a gas to a liquid, we call that condensation. Now, the only thing we haven't talked about is going between solid and gas. When we go from a solid to a gas, that is called sublimation. And then when we go from a gas to a solid, that's called deposition. And so if you need more time to write this in, go ahead and pause the video at any point.